Hello. Now we'll see the charge distribution on a multiple plate. So we are taking the two plates, two metallic plates. Now this one, both of these plates are metallic. So there are two metallic plates and we have given the charge plus Q1 onto the plate 1, I'm calling it plate A, and the plus Q2 to the plate B. So there are in total of 4 sides. This is 1, 2, 3, 4. These are 4 sides. So since I'm giving this plus Q1 charge onto the plate A, some of the charge will go to the one side and some of the charge will go to the other side. So I've assumed this charge to be plus Q, small q. So out of the capital Q1, plus Q charge went to the side 1. So remaining charge, which is Q1 minus small q, will go into the plate 1. Now coming back to the plate B, the plus Q2 charge was given to plate B. And out of that, we have assumed plus Q dash is coming onto the side 3 and the remaining charge, which is Q2 minus Q dash, is going to the side 4. Okay. And we have taken all the charges positive. If some charge is negative, all you have to do just replace the sign in front of that charge. Okay. So now we want to see these values of small q and Q dash. Okay. So that we can calculate how the distribution is taking place and the relationship between the charges onto the either plates. There are 4 sides, either sides. Okay. So what I'm doing here is I'm assuming 2 points. Point P I'm assuming inside plate A, and there is another point Q I'm assuming, this is not Q, this is small a and this is small b. There are these 2 points I'm assuming, one inside the plate A and another inside the plate B. Okay, so since these 2 plates are metallic plates, and we know regarding the metallic plate, inside each and every point of the metallic plate, electric field is always 0 at steady state, obviously. So electric field at point A, small a, and the electric field at point small b will be 0. That's the definition, meaning it is a metallic plate, conductor. Okay, so based upon that, we'll be making the relationship between the charge distribution. Okay, so let's talk about point A. So for point A, so electric field at point A should be 0. Now this point A will experience 4 electric field. One coming from this surface, surface 1, one coming from second surface, another coming from third surface, and another coming from fourth surface. And since all the charges I have taken positive, so because of the positive charge particle, electric field will always be away from the positive charge particle. So if I talk about this point A will experience electric field E1, right direction. E2, which is coming because of this charge distribution, will be in this direction. E3, coming because of this charge distribution, because this is positive, will be in this direction. And then there is a E4 because of the 4th charge distribution. Okay, so these are plates. Now we put one more condition, because these 2 plates we are dealing, so that we can utilize the formula which we are going to get here in case of capacitance. Okay, so I will use that condition here. So the condition here is the distance between these 2 plates is very, very small. Distance between the plate is very small compared to the cross-section area of the plate. So dimension, this dimension is very small, very, very small. If the cross-section area is capital A, for both the plates I'm taking the same cross-section area. If capital A is the cross-section area and this D is the distance, then I'm assuming that dimension of D very, very, very small than the dimension of A. We cannot compare the distance with area. I'm talking about dimension. So if this is millimeter, this should be meters, like that. Okay. So based upon that, we can say for point A, all 4 surfaces, they will look like they are of infinite dimension. So this point A is very nearby to all 4 surfaces. All 4 surfaces. In the diagram, it might look like that this point A is closer to 1 and 2, but not closer to 3 and 4, but it's not the case. This distance is very small and thickness is also very small for the plate. So all these plates, they will look like, for the points, they will look like they are at a same location. So based upon that, we can utilize a formula. We have a formula. So if you remember, the electric field formula, because of the infinite charge distribution, plane distribution, formula is sigma upon epsilon naught. This is the formula. This is the field due to infinite dimension plate nearby to the plate. So since these points are very nearby to the plates, I can utilize this formula. Okay, so let's calculate E1, E2, E3 and E4. So basically, electric field at point A will be E1, the right hand side, this direction I am taking positive, and opposite will be taking negative. So E1 minus of E2 minus of E3 and minus of E4. So let's put the values of these. So if I put the value of E1 will be equals to sigma upon epsilon naught. To get the sigma, we need total charge divided by cross-section area, which is capital A. So total charge on the plate 1, this is Q1 minus small q. So Q1 minus small q divided by capital A, epsilon naught, minus of small q upon A, epsilon naught. On the second side, the charge is small q. Now we go for the third side, the charge is q dash. Q dash divided by A, epsilon naught. And the fourth side, it is Q2 minus Q dash divided by A, epsilon naught. And the whole value is 0. So let's combine all these values. If we are going to combine all these values, if you add these two, it will be capital Q minus 2 small q upon A, epsilon naught, and minus, if you take the minus common, it will be Q2, this is Q1 actually, Q2 upon A, epsilon naught. And this value is 0. So that makes Q1 minus Q2 is equals to 2 times of Q. That is your equation 1. Because we want the values of small q and q dash in terms of Q1 and Q2. Okay, this is your equation 1. Now I'll perform the same operation, but this time with point B. So EB, electric field at B. So if you see at B point, these three sides and this one side. So because of this charge distribution, electric field will be away from the charge distribution. So E4 will be in this direction. Now there is this 3 which is on the left side. So electric field because of 3 will be onto the right side. Then there is this 2, E2, and then there is this E1. So EB will be equals to E1 plus E2 plus E3 minus of E4, and that will be equals to 0 because the B point lies inside the conductor. So let's put the values of E1, E2, E3, which we have already calculated actually. So E1 value is here. So it will be Q1 minus small q upon A, epsilon naught, plus then comes the E2, small q upon A, epsilon naught, plus then comes the E3, q dash upon A, epsilon naught, and then comes the E4 which is in negative. So minus the E4 is Q2 minus Q dash upon A, epsilon naught, and that value is equals to 0. Okay. So let's add all these values. So if I add these two, this small q minus and this q will cancel out. And A, epsilon naught from the denominator I can take common, and that right inside there is 0. So it will be Q1, this and this cancel out, plus Q dash minus Q2 plus Q dash is equals to 0. So that makes the second equation. And second equation is Q1 minus Q2 is equals to minus of 2Q dash. Or we can say Q dash is equals to Q1 minus Q2 upon 2 and in negative. So this negative I'm taking it here. This is the value of Q dash. And if you see it here, the value of small q is Q1 minus Q2 by 2. Okay, so we get the value of q and q dash. Let's get the value of q1 minus small q also, because this is the charge on plate 1. So now I've got the charge on plate 2, charge on plate 3. Now let's calculate the charge onto plate 1, which is q1 minus q. So q1 minus q, if you do, so q1 in place of small q, you will be writing q1 minus q2 upon 2. Okay, so if you do that, the value you will get q1 plus q2 by 2. So that is your charge on plate 1. Now let's calculate the charge on plate 4 as well, which is q2 minus q dash. So q2, if you do subtraction, there is this negative already there, so it will be positive q1 minus q2 upon 2, and that value you will get q1 plus q2 by 2. That's your q2 minus q dash. So this is the charge on plate 4. Okay, so we have got the charge on all 4 plates. Now let's summarize these charges. Let's put these charges onto the plates. So we are having 2 plates, this one and this one. And for the plate A, we have given plus q1 charge. Now, this side was 1, this is 2, this is 3, and this is 4. So onto side 1, we got q1 minus small q. This is the charge. So here the charge was q1 plus q2 by 2. And the side 2, the charge was plus q, small q. So here the small q value is there. So positive capital Q minus capital Q2 upon 2. Then there is a third plate, which is the q dash, which is this value. The charge here was not positive. First of all, it is negative. So that's the thing. And the magnitude wise, it is q1 minus q2 by 2. And the last plate, the charge is q1 plus q2 by 2. So now you see, when we are giving these charges, any charges you are giving, any charge you want. So average of that charge goes to the outermost surfaces. So we have given q1 to the plate 1, q2 to the plate 1. The total charge given, total charge given was q1 plus q2. That was the total charge given. So out of the total charge given, half of the charge is going on to this outer surface and half of the charge is going on to this outer surface. But at the same time, there's the induced charge as well. When you talk about the inside surface, one side of the inside surface is becoming positively charged and another side of the surface is becoming negatively charged. Now, which one is actually positive and which one is actually negative, that will depend upon the relative values of q1 and q2. So if q1 is greater than q2, if the plate A is getting more positive charge than the plate B, in that case, the plate A, inner side of the plate A will be positive, because then q1 minus q2 will be a positive value. And q1 minus q2, here it is negative. But if q2 is more than q1, the reverse will happen. So average of the two charges going on to the outer surfaces and inner surfaces are having opposite sign of charges, and they are taking the difference, average of difference of the charge onto the inner surface. So finally, we are getting this side is q1 minus q2 by 2, this side is minus of q1 minus q2 by 2. And outer surfaces are having average of the two. And if you add all four charges, charges when you add 2 and 3, they become 0. And if you add these two, it becomes q1 plus q2, because you cannot generate extra charges. Whatever charges are there, they will remain there. Okay, so this is the outcome when you have two metallic plates, and if you are providing those two metallic plates some charge, q1 and q2, then first thing, if you want to calculate how the charge is getting distributed, some points you can directly remember. One point is average of the total charge will go on to the either side, outside. So average of the total charge. Then inside surfaces, one side of the inside surface will be positive, another will be negative. To check whichever is receiving higher positive charge, that will be positive, another will be negative. Now what will be the magnitude? You just take the difference. So difference of the average of difference of the two charges, average of the difference of two charges will decide the magnitude of inner sides. Okay, so these points you can memorize directly. We can utilize these points while solving the question, as well as the derivation also you can check. This derivation will help you in CBSE as well and other state exams. Okay, so that's it. Thank you.